Hello guys. In today's tutorial, we'll be looking at how to use the operational amplifier. So it's an electronic device we're going to learn how to use today. In the past tutorials, we've looked at how you can install Proteus on your PC and then draw several circuit diagrams on your PC. So today we'll be looking at how you can use an operational amplifier. Let me pick one of it, one of my favorite, LM324. So here it is. Um, this is an operational amplifier. So we're going to look at what this operational amplifier is and how it works. So operational amplifier is an electronic device that has two differential inputs and one output and a single-ended output. So these are the two differential inputs and a single-ended output. So these two differential inputs are the Vin plus and the Vin minus. Okay, they are the two differential inputs, while the output is the V out. So the Vin plus is called the non-inverting input and the Vin minus is called the inverting input. So these are the two inputs that you give to the op amp and this is the output. So note that the op amp comes in different IC. There are so many ICs that are operational amplifiers. So when you want to use each one, you have to study the pin out to actually know which pin is inverting input and which pin is non-inverting input. So we are still going to look at the pin out of LM324. But before then, let's understand what these two pins do. So the inverting and non-inverting input. So how this op amp works is you apply voltages to these two inputs. You apply voltage here and you apply voltage here. So if the voltage in the Vin plus is greater than the voltage in the Vin minus, then the V out is high. But if the voltage in the Vin minus is greater than the voltage in the Vin plus, then the V out is what? Low. Okay, so this is just the basic way that the op amp works. Just note this and write it somewhere. That when the voltage in the Vin plus is greater than the voltage in the Vin minus, the V out is what? Is high. And when the voltage in the Vin minus is greater than the voltage in the Vin plus, the V out is what? Is low. Okay, so this is just how the op amp behaves. This is the basic behavior of the operational amplifier. And we're going to use this behavior to develop different circuits. So, but I still need to show us something on this behavior. So let me pick a battery. I'm going to pick a battery and I'm going to pick a battery and then I'll pick a potentiometer port. So I'll pick a potentiometer. I'll pick this one that is active. I've told you about active and device. If you want a component that can simulate, you select the active. Okay, so let me keep this battery. I'll be using it to power this system. And let me pick the potentiometer. So I'm going to be using the potentiometer to vary the voltages that I'm sending to these two pins. Okay, so it has button here. I can vary the voltage. I can increase and reduce it. So I'll connect the positive of the battery here. And I'm going to loop their two together and connect it to the negative. And basically I'll connect it to ground. Okay, let me pick ground, put it here. So this other pin, I'll take it to ground. Don't worry, I'll tell you what these pins are. And this other pin, I'll take it to VCC. And I'm going to pick an LED. Okay, I'm going to pick an LED. Alright, so and we'll connect the LED here. Remember I taught you earlier, if I'm simulating on Proteus, I can actually connect this LED directly, no problem. But in real life, I must put a resistor here, otherwise the LED will be what? It will damage. Okay, so let me compile this. Okay, so this turned off. So, but to prove to you what this is, I'm going to pick a voltmeter. So if you want to pick measuring equipments on Pro Tools, this is where you come. Like I told us that as we go on and we need any tools, we will learn how to pick it. So this is where you come to pick your measuring tools. We have the DC voltmeter, AC voltmeter, AC, DC voltmeter, DC ammeter, AC voltmeter, AC ammeter, and wattmeter. Okay, so I'm going to pick the DC voltmeter because the voltage I'm measuring here is the DC. So I'll have this here to measuring the voltage going to the non-inverting input, and I have this here to measure the voltage coming to the inverting input, and both of them are common to ground. Okay, so I will simulate. Now, as we can see, the voltage from the non-inverting input, the voltage from the inverting input, which is the Vn minus, is greater than the voltage from the non-inverting input, and here the LED is off, meaning the voltage coming here is low. Now let me make the voltage here greater than here now. So I'm going to increase the voltage. So immediately the voltage at the non-inverting input supersedes the voltage at the inverting input, the output becomes high. So I want you to note this somewhere, that whenever the Vn plus is greater than the Vn minus, the output is high. Whenever the Vn minus is greater than the Vn plus, the output is what? Low. Because this is the basic operation of this man. That's the basic operation we are going to do what? To work with. So I did this just to prove the operation so you can actually do what? Understand the operation. So having understood the operation, I will simply remove these things, and I will remove all of them. So this is the op amp. So let's look at LM324. Let's look at it as an IC. So we can actually understand the LM324. So this is the pin out of LM324. It's a 14 pin IC. This is the notch. So as we can see, we see that this IC has 4 op amp inside it. This IC has 4 op amp. 1, 2, 3, 4. So it has 4 op amp inside it, and each of these op amp can work independently on anyone. This op amp can be working on its own. This can be working on its own. This can be working on its own, and this can be working on its own. What this does never affects what this does. Okay, so as we can see, this is the inverting input 1, non-inverting input 1, and the output 1 for this one. For the second one, we have non-inverting input 1, 2, inverting input 2, and output 2 for this one. So if I'm putting input here, I should be taking output here. I cannot be putting input here and I'll be trying to take output here. Okay, so if we relate this to what we have on Pro Tools, let me show us now. If we relate this to what we have on Pro Tools, you can see that this is the first one, 3. It's 3 here, non-inverting input 1. This is inverting input 1, and then the output is pin 1. Okay, and then these other 2 pin are the VCC and ground for LM324, which is we can see here pin 4 is VCC and pin 11 is ground. Okay, so this is the operating voltage of this LM324. It has a wide range of operating voltage. Alright, so if I drop other op amps here, this second one, you see that it automatically selects this second one. Likewise, if I drop a third one, it selects this third op amp and a fourth one. So it does this selection automatically for you. And when you watch, their VCC and ground pin remains uniform to all of them, telling you that all these are one IC. And when you check the Pro Tools label, you see that this is U1A. If I drop another one, okay, let me drop it here. See that it is U2. That means this is a second IC. Okay, but it recognizes these 4 as one IC. So let me remove them. So having understood the pinout of this op amp and how it works, so the next thing we are going to look at now is how can we actually use this op amp. So we are trying to use this op amp as a comparator. So how do we use this op amp? So remember that we will be feeding voltage to these 2 pins. Okay, so we will be using what we call a voltage divider circuit to feed voltage to this circuit. So what is a voltage divider circuit? Let me pick a resistor. Okay, so this is a resistor now. Um, when I have two resistors connected in series like this, okay, these two resistors are connected in series. There is always a voltage drop here. Okay, so measuring this voltage drop is just the voltage that divides between these two resistors. That is the voltage divider. So um, with the voltage divider rule, I have a little document here. With the voltage divider rule, where you have a circuit like this and you are putting your V in here and you are trying to know the voltage drop at this particular point, which is the V out. The V out is equals to R1 plus R2 all over R2 times V in. Okay, that is the formula. Though we are not going to be specifying this formula in what we are going to be doing, but let me show us something briefly on Proteus. Let me show something very briefly on Proteus. So, if I have this circuit here like this now, and I'm putting a V in here, let me say I'm giving it 5 volts. Let me work with this battery now. Let me work with this battery, and I can edit this voltage, and let me say I'm working with 5 volts, for instance, okay? And this at the ground here. Okay, so what we need is, let's know the voltage that drop here. So I'm going to get this voltmeter again, this DC voltmeter, put it here in order to measure the voltage. Okay, now let's simulate this. So what we have here is 5 volts, and R1 is equals to R2. We're having 2.5 volts. I want us to, this is the first scenario, I want us to know this. So 2.5 volts is actually half of 5 volts. So that means that with the voltage divider, whenever R1 is equals to R2, then the V out is equals to half of V in. Half of V in. I want us to know this. Whenever R1 is equals to R2, V out is equals to half of V in. Because here now, the R1 is equals to R2 and V out is half of V in. So let's increase R1 now. Let's make R1, let's say 20K. Okay. Let's make R1 20K and let's simulate the circuit. You watch that the output voltage now is lower than half of V in. Are you with me? The V out is lower than half of V in. Listen, I'm trying to create. Let me keep this way. Okay, I'll zoom this in. All right, so I think this is good like this. So I'm trying to lay an emphasis, and when you follow this emphasis I'm laying, understanding this will be very easy for you. Okay, so whenever the R1 increases, V out reduces. Are you with me? Whenever R1 increases, V out will reduce. Then let me take this out. Let's continue only here. Okay, let me reduce this back. Let me start simulation. Let me reduce this back. And it's 10K. And let me increase this. Okay. Let me make this 20K now. And let's simulate. So you see that the V out grew higher than half of the V in. So with the emphasis we will have now, so whenever R1 here is increasing, V out will be reducing. But whenever R2 is increasing, V out is increasing. Okay? Whenever R2 is increasing, V out increases. And when R2 reduces, V out reduces. But R1, when R1 increases, V out does what? Reduces. Because here now, let's increase this a bit now. Look at what we have. Look at what we have here. Okay, we are having uh 3.3. Okay, now increase this a little bit. Let's say we'll have something like 15K here. It's not up to 20K, it's 15K. Now let's look what happens. You see that this does what? Reduces. So whenever R1 increases, whenever the resistance here increases, the voltage at the V out reduces whenever you have your connection like this. So this connection is being used in many cases. So we just need to study this and know this. Then note another thing, that if I increase this V in, V out increases. That one is automatic, okay? The V in is directly proportional to what? The V out. Also, note that. So you can apply this. They will do many projects in the future whereby we will apply this voltage divider principle. So go and save this somewhere and save it very, very well so that when we get there, you can actually follow with what we are doing. And having understood how the operational amplifier works and having understood how the voltage divider works. So we're going to be stopping the tutorial here, and in the next tutorial we'll be doing several projects which will be involving this operational amplifier and this voltage divider that we've just learned in this tutorial today. So the different projects we'll be doing are we'll, monitor shadow, we'll monitor temperature. All these have sensors that for you to use them, you must configure them with the voltage divider. So stay tuned with us. Like the video if you liked what you watched, and subscribe to our YouTube channel for more video. Thank you very much for watching. Stay tuned for more video.